we have three distinct roots, p, q, and r, of x cubed minus 22x squared plus 80x minus 67. When we're told that there exists real numbers a, b, and c such that this new equation, 1 over x cubed minus 22x squared plus 80x minus 67 equals a over s minus p plus b over s minus q plus c over s minus r for all s not equal to p, q, and r. So essentially, because, well, why p, q, and r? Because then this would be 0, right? And you can have that. Okay, so now we're trying to find the value of 1 over a plus 1 over b plus 1 over c. Okay, so first things first, this is really just an example of partial fractions, which you don't really need to know the name for this. It doesn't really change what you do. But just so you know, this is just really partial fractions, and this is mostly used in calculus because when you integrate a fraction like this, it's easier to integrate some simpler fractions like this than to integrate a whole random fraction like that. So that's usually where you use this, but anyways, here we go. Okay, so partial fractions. Okay, there we go. So really the first step is to get rid of all of these fractions, right? And by doing that, well, to do that, you can multiply by s minus p times s minus q times s minus r, right? And that gives you, well, s minus p times s minus q times s minus r over s cubed minus 22s squared plus 80s minus 67 equals a times s minus q, s minus r, it's taking a long time, plus b times s minus p, s minus r, yeah, I can move over now, plus s minus, times s minus r plus c, times s minus p, times s minus q. Okay, step 1, write the question, check. Okay, and now we see, well, okay, essentially this is true for every single s, right, other than p, q, and r, but now that we multiplied by s minus p and, well, just made these non-fractions, this constraint goes away, right? This can, no, now it's just for all s, right, here it is. Right, that constraint goes away because, well, that was only there because these can be 0, right? But now they could be 0, which is what we're going to abuse right now. Okay, so first of all, we see this fraction over here is, well, s minus p, s minus q times s minus r over this. Well, p, q, and r are defined as the roots of s cubed minus, of this cubic, right? Of that cubic. Which means, well, this cubic is literally defined as s minus the first root times s minus the second root times s minus the third root. Which means this thing is just 1, which is really where the fun part comes in. And okay, now again, like I said, we're going to start abusing the fact that you can make s equals to any number, including p, q, and r. Okay, so first thing, let's just make s equals q. Again, for any real number, s equals q. That works, right? And if s equals q, what happens? Well, then you get a times q minus q times q minus r times b times q minus b times q minus r, on, right? However, here you have a times q minus q times s minus, times q minus r. This is just 0, right? So that means you just get 0 plus b times q minus p times q minus r. Oh boy, here we go again. B minus r. Q minus r, sorry. Q minus r, and this is also 0, right? C times q minus p times q minus q, which is 0. So plus 0 equals 1, which means, well, b times q minus p minus r, well, there's no need to write that, just this equals 1, right? And well, now we can find b, or rather 1 over b, because we're trying to find the sum of 1 over a and 1 over b and 1 over c. So that means 1 over b equals 1 over b, it's the fattest b ever, 1 over b equals q minus p times q minus r. Q minus r, right? Because, well, you just divide and then flip. Okay, so that's the first piece, right? First piece. And now, well, I told you I was going to abuse it. So now let's make s equals, say, r. Right? If s equals r. Well, then now, this is still 0, right? You get, well, s equals r, you just get r minus q, r minus r. That's still 0. This also becomes 0, right? Because you have the r minus r. So now finally you just get c times r minus p times r minus q equals 1, which means, well, now we get 1 over c equals r minus p, oh my gosh, r minus p times r minus q, which is the second piece of our little puzzle. Right, r minus p times r minus q. And okay, now for the last piece of our puzzle, where we find if s equals what's left p, we can find what a is, right? Because then we get p minus p 0, p minus p 0. That means we get a times p minus q times p minus r equals 1, so we get 1 over a equals p minus q times p minus r, which is the third step. So now we're almost there. Well, it seems that we're almost there, but really, finding the sum of these three pieces is not an easy thing to do either. Okay, so let's actually go ahead and make a little divider, because we do have to see this stuff to continue. Okay, so now, once you add these up, what happens? Well, this expanded is really q squared plus, well, sorry, minus qr minus pq plus pr, right? And that added to r squared minus rq minus pr plus pq. And it would be a shame if anybody messed up on this step, so just be a little bit careful. Okay, so now you get, well, this is p squared minus pr minus qp plus rq. And well, once you add everything up, you just get, well, first of all, pr can cancel with negative pr, so really these two can go away. Plus pr minus pr goes away. And then, well, pq and minus pq goes away. And rq and qr, rq, same thing, also cancel, right? And that leaves you with grand total of q squared plus r squared plus p squared minus qr minus pr minus qp, right? And okay, well, don't forget, we still don't know actually what pq and r are, because they're just roots of this, and trust me, don't even try to find the roots of this. They're gonna make it like so complicated that you're never gonna get a chance at actually finding what the three roots are. That's just how it's designed. Trust me, I've tried that. You don't want to try to find the three roots. Instead, you have to use something. Let's do it up here. Something called Vietas, which is something, well, some formulas rather, that are really, really useful for a whole lot of questions, right? And here, because you have a cubic, you're going to use Vietas for a cubic, which tells you that the sum of your roots, rs and q, or no, PQ, sorry, not rs S and G. P, Q, and R, their sum is equal to negative 22 over 1, or negative B over 1, which would give you equal to 22, positive 22. My goodness, positive 22. And then we get their pairwise sums, which is just the pairs of them added together. Okay, plus PR plus QR equals, well, positive 80 over 1. And then finally, you don't really need this here, but just for some completion, we get the product is negative 67 over 1, which is just positive 67. And okay, well, that means their sum is 22. Of course, you don't really need this, because their sum is 22 and their pairwise sum is 80, which means all the way on the other side of the world. We can not apply this here. Okay, so why can't we use this? Well, first of all, this really is just minus 80, right? However, we still have this q squared, r squared, p squared. And actually, you can't just, take this squared and be like, that's p squared, q squared, r squared, because you get a whole bunch of other terms. However, that is good thinking, because you could still use something like this, right? P plus q plus r, P plus g plus r. Nice. P plus q plus r squared. That's still useful, because this is equal to what you want, right? Plus some excess, right? Plus 2pq plus 2qr plus 2pr, 2pr, or essentially just the squares plus 2 times their pairwise sums. And actually, I'm not going to figure out what this is just yet, because, well, now we see what we want. This thing is just, the thing that we want is just the sum of them, q plus r plus p. That thing squared minus, now it's minus because you're going to subtract off the excess, 2 times their pairwise sum. QR plus PR plus QP. However, you still have this minus thing going on here, so that means really you're taking minus 2 of the pairwise sum minus a third pairwise sum, which is just minus 3. Which means finally you get this, their sum was 22 squared minus 3 times 8, and 22 squared, I believe, is 584. 484. How about that? Don't tell anybody else. Okay. 484 minus 240, which gives you an answer of 244 at the end of this ordeal. Question. Okay, which would give you an answer of B.